In this video, an artificial agent learns to balance an inverted pendulum. What makes this video unique is that you do not just see a balanced pendulum, you also see inside the agent's mind. Through animations, you can follow the pendulum motion at different stages of training and how the agent's internal memory evolves over time, showing how it learns which actions to take to prevent the pendulum from falling. The angle exceeds 45 degrees in either direction, the episode fails. And it's not just about staying upright, the agent must do it using as little energy as possible. The frame on the left represents the environment. It shows how the agent controls the pendulum. It also displays information such as torque, speed, and angle. The frame on the right shows the agent's memory. Lighter colors indicate higher values. The lower plot shows the policy, torque, as a function of angle and angular speed. The training now begins. The red arrow represents the applied torque, which is the agent's output. The animation is now paused to reflect. In these first episodes, the policy was random. Consequently, every episode ended in failure after just a few steps. Now we fast forward to above 150 episodes. One observation is that the replay buffer has increased significantly in size. It now contains almost 4,000 items. An item corresponds to a step in any executed episode. Another observation is that progress has been made. The typical number of steps is now around 50 instead of just a few, as at the beginning of training. There is a preliminary agent memory in place. It sometimes applies negative torque and sometimes applies positive torque. However, more training is needed. Now almost 250 episodes has elapsed. Success. We can now observe the desired behavior. The pendulum does not fall. The value function shows that high speed, combined with a large angle, is deemed to lead to failure, marked by black areas. The black area in the policy plot indicates that negative torque should be applied when the angle is positive, with some adjustment for angular speed. The white region represents the opposite. Positive torque should be applied when the angle is negative, also with some adjustment for angular speed. The gray area is interesting. It indicates that in some cases, zero torque is appropriate. This is a natural choice when the pendulum is upright and still. For a small positive angle and moderate negative angular speed, zero torque is proposed. This can be interpreted as do nothing, let the rotational energy cause the pendulum to become more upright. An intelligent and energy-saving behavior.